You know, Alex, I was looking at that old wooden mallet I made back in the 90s. If it didn't hit hard enough, I just glued more leather to the face. If the handle cracked, I wrapped it in twine. It was honest. But this morning I spent 2 hours arguing with a machine that has the temperament of a caffeinated squirrel because the plastic noodle decided it didn't want to come out of the tiny brass straw.
Welcome to the future, Tiger, where the undiscovered country isn't space. It's the first layer of a PLA benchy. You look like you haven't slept. Did you stay up watching the nozzle again?
I was transfixed. It's like watching a slow motion train wreck where the train is made of melted Lego. I had a blob of death so big it looked like the printer was trying to grow its own lung. I think it's sentient, and frankly, it doesn't like my tone of voice.
Well, since your printer is currently staging a silent protest, I figured today we should actually dive into why these things act like temperamental toddlers. We're talking 3D printing troubleshooting, because as much as we love the set it and forget it dream, the reality is more tweak it until you want to throw it out a window.
It's a specialized kind of torture, but I've been through the fire literally once when a heater block went rogue, and I've gathered some wisdom, or at least I've gathered a very large box of failed print spaghetti that I'm keeping for no reason.
Let's start at the very beginning. The ghost print. You hit go, the motors are whirring, the head is moving, but absolutely nothing is coming out. It's just tracing patterns in the air. What's the first thing you're checking before you lose your mind?
Usually it's the vanishing act. You go to start a print, and for the first 30 seconds, the nozzle is just dry heaving. People think the nozzle is clogged, but often the plastic simply leaked out while the machine was preheating. I call it nozzle drool. While that brass tip is sitting there getting up to 200 degrees, gravity is doing its work, and the filament just oozes out.
So the nozzle is basically empty when it actually starts its first line?
Exactly, it's like trying to get ketchup out of a fresh bottle. You're shaking it, but nothing's happening for the first few squirts. That's why you have to prime the pump. I always throw an extra skirt or a brim around my parts in the slicer settings. It forces the printer to draw a couple of circles around the perimeter first. It clears the throat of the machine, so by the time it gets to your actual part, the flow is steady.
Okay, but what if the nozzle is primed, but it's still acting like it's being starved? I've seen that happen where it's just thin, like it's printing with a spider web instead of plastic.
That's the ghost of friction. Sometimes your filament is getting tangled on the spool. If that spool doesn't spin freely, the extruder motor is basically playing tug of war with a 5-pound weight. Or even worse, the drive gear, that little jagged wheel that bites into the plastic, has filled up with plastic dust. It loses its grip and just starts polishing the filament instead of pushing it. It's like trying to drive a car on ice with bald tires. You're spinning, but you ain't winning.
Spinning, but not winning. I'm stealing that. But let's talk about the most heartbreaking failure. Everything looks perfect for the first hour, and then you come back and the print is stuck to the nozzle, being dragged around the bed like a trophy. Why won't the first layer just stay put?
Bed adhesion blues. This is the cornerstone of 3D printing misery. Usually it's a dignity issue. Your print bed has to be surgically clean. Skin oils are the enemy. If you touch that glass or PEI sheet with your greasy fingers after eating a sandwich, that print is going to pop off. I keep a spray bottle of high percentage isopropyl alcohol like it's holy water.
So it's just a cleanliness thing? Because I've seen people using glue sticks, hairspray, and even some weird sugary concoctions to get things to stick.
That's the old world magic. Glue sticks are great because they provide a sacrificial layer. But before you go raiding the craft cabinet, check your nozzle height. If that nozzle is even a hair too high, the plastic is just laying on the bed instead of being squished onto it. You want that first layer to look like a slightly flattened pancake, not a round noodle. If it looks like a tube, it's going to fail. If it looks like it's being smeared into the bed like butter on toast, you're in the sweet spot.
What about the warp factor? I've had prints that start great, but then the corners start lifting up and curling like a dried up orange peel. It ruins the whole base of the part.
That's thermal stress. Plastic shrinks as it cools. If the bottom of your print is staying hot because of the heated bed, but the layers above it are getting hit by a cold draft from an open window, the top layers pull on the bottom ones. It's a literal tug of war. For materials like ABS, you basically have to build a little sauna around the printer and enclosure to keep the air still. For PLA, usually you just need to dial back the cooling fan for the first few layers.
Let's move up the print. Stringing. The Spider-Man effect. You print two towers, and there are thousands of tiny, hairy whispers of plastic connecting them. It looks like your printer has been taken over by cobwebs.
That's the ooze. It happens when the nozzle moves from one point to another without extruding. Think of it like a hot glue gun. If you move it, it's still going to leave a trail. The fix is retraction. Your printer actually sucks the filament back up a few millimeters before it moves. If your retraction speed is too slow or the distance is too short, the pressure stays in the nozzle and it leaks. It's like trying to stop a garden hose by just turning the nozzle. If there's pressure in the line, it's going to drip.
You mentioned heat earlier. I've seen some prints that look melted, like the fine details just turned into a blobby mess. Is that just too much heat, or is the printer moving too slow?
It's both. If you're printing a tiny little chimney on a house, the nozzle spends all its time in one small area. It's dumping heat into that spot faster than the plastic can solidify. It stays molten. It's like trying to build a sandcastle with soup. The trick there is actually a bit counterintuitive. Print two of them.
Wait, print two identical parts to fix a heat issue?
Exactly. If you print a second part on the other side of the bed, the nozzle has to travel away from the first part, giving it time to catch its breath and cool down before the next layer comes around. It's giving the plastic a timeout to firm up.
Okay, Tiger, explained this one. I was printing a gear for a project, and halfway through, the printer decided the center of the universe had shifted 2 millimeters to the left. The top half is perfect, the bottom half is perfect, but they aren't on the same planet.
That's a layer shift. That's usually a mechanical heart attack. Somewhere in the middle of that print, something got caught. Maybe a belt skipped because it was too loose, kind of like a bicycle chain jumping a tooth. Or, even more sneaky, your stepper motors might be overheating. If those motors get too hot, they just give up for a fraction of a second. They lose their place in the world.
So I'm checking belt tension first?
Always. Give them a pluck. They should sound like a low guitar string, not a wet noodle. And make sure the little grub screws on the pulleys are tight. If those are loose, the motor turns, but the belt stays still for a heartbeat. In this shop, we don't tolerate slop in the drivetrain.
Slop in the drivetrain sounds like a country song. What about Z-banding? Those horizontal ripples that make the sides of a print look like a plowed field?
Oh, the wavy gravy. That's almost always the lead screw, the big threaded rod that moves the head up and down. If that rod is even slightly bent, or if it's got a bit of grit caught in the threads, it'll wobble. As it rotates, it pushes the nozzle back and forth ever so slightly. It's a rhythmic error. You can see the pattern. It's like a signature of a bent sole, or just a bent piece of cheap steel.
Let's talk about the clog, the big one. The moment you realize your $500 machine is being defeated by a grain of dust. How do you perform surgery on a clogged nozzle without ending up in the emergency room?
I've spent more time staring into the business end of a nozzle than I care to admit. First rule, don't stick a sewing needle in there while it's cold. You'll just snap the needle and then you've got a real problem. I'm a big fan of the cold pull.
Which sounds like something you'd do to a muscle at the gym.
Close. You heat the nozzle up to its melting point, then turn the heat off. As it cools down to about 90 degrees, where the plastic is firm but still a bit stretchy, you yank it out manually. If you do it right, the plastic comes out in the shape of the inside of the nozzle, and it brings all the burnt bits and dust with it. It's like a pore strip for your printer. It's deeply satisfying to see that little plug of gunk come out.
That actually sounds strangely therapeutic.
It is, right up until the point you realize the clog was caused by cheap filament. Look, I love a bargain. I'll buy a used lathe from a guy in a parking lot any day, but cheap 3D printer filament? It's a trap. Sometimes the diameter varies too much. If it gets too thick, it jams in the tube. If it's too thin, the extruder loses its grip. It's like trying to feed a garden hose through a straw. It's got to be exact.
I've also heard that filament can get wet. Like, it absorbs moisture from the air? How can plastic get wet? It's plastic.
It's hygroscopic. It drinks the humidity in the room. If your filament has been sitting out, it absorbs water molecules. When that water hits the 200-degree nozzle, it turns to steam. It literally pops inside the nozzle. If you hear a crackling sound while you're printing, your plastic is basically a bowl of Rice Krispies. It leaves tiny bubbles and pits in your print, ruins the strength, and makes the surface look like it has acne.
So we need a plastic dryer now? Another machine to fix the first machine?
You can buy fancy ones, but I've used a food dehydrator in a pinch. Just don't tell my wife why the jerky tastes like summer rain PLA. The key is just keeping it in a sealed box with those little silica gel packets. Give your plastic a fighting chance.
Okay, let's talk about the inside of the print. The infill. I've had prints that look gorgeous on the outside, but when I break them, the inside looks like a mess of broken toothpicks. It's weak and crunchy.
That's under extrusion. Your printer is being stingy with the plastic. If your infill is weak, you might be printing too fast. The heater block can't melt the plastic fast enough to keep up with the speed of the motor. It's like trying to get hot water out of a small heater while 5 people are taking a shower. Eventually, it just comes out cold. Or in this case, it comes out unmelted and thin. Slow it down. In woodworking, we say measure twice, cut once. In printing, I say slow down the speed, save the lead.
You're full of these today. Save the lead.
I'm trying, Alex. It's a work in progress. But seriously, slow is smooth, and smooth is fast. If you try to break the land speed record with a $200 hobby printer, you're going to get a pile of lace instead of a solid part.
Speaking of solid, what about pillowing? Those weird little holes or bumps that appear on the top flat surface of a print. It looks like the printer is trying to cover a hole, but the plastic just falls through.
That's exactly what's happening. If your infill is too sparse, meaning there's too much empty space inside, the top sealing layers don't have enough to rest on. They sag. You need more top solid layers. I usually go with at least 4 or 5. It's like decking a roof. You wouldn't put shingles over rafters that are 4 feet apart. You need a solid base. Also, make sure your cooling fan is 100% on for those top layers so the plastic bridges those gaps without drooping.
You know, for all the complaining we do about these machines, they're still kind of miraculous. You essentially manifested a physical object out of a digital thought and some spaghetti.
It is a miracle, a frustrating, hair-pulling, confusing miracle. But there's a moment, usually right after you peel a perfect print off the bed and the bottom is as smooth as a mirror, where you forget all the clogs and the leveling issues. It's that same feeling I get when a dovetail joint slides together perfectly. It's the click of things working the way they were meant to.
So, what's the big takeaway for someone who's currently staring at a bird's nest of plastic and feeling like a failure?
Don't take it personally. These machines aren't judging you. They're just following the laws of physics. And physics is a strict teacher. Most problems are just a triangle of 3 things: heat, speed, and distance. If it's not sticking, check the distance. If it's stringing, check the heat. If it's messy, check the speed. Usually the answer is simpler than you think. It's rarely the brain of the computer. It's usually just a dirty bed or a loose screw.
Just like in the wood shop, it's usually the simplest thing.
Exactly. The tools change, but the craftsman's patience stays the same. Now, if you'll excuse me, I have to go apologize to my printer. I think I hurt its feelings when I called it a glorified hot glue gun earlier.
Go mend those fences, Tiger. Maybe buy it some high-quality filament as a peace offering.
Maybe some glitter gold. Everything looks better in glitter.